Bobby Cole here, Think-PLC, president of the company, leading up projects like you see here. What you're looking at is not only a robot, that's the obvious thing you see in the background, industrial grade robot that has been made to work in a machine tool environment. So we have a Think-PLC custom design control system running the Numeric, which is an amazing machine tool product, controller, Synamics drives, I/O, fully IPC deployed operate system that turns an industrial robot into a full machine tool controllable device. So what's special about this is, one, the amazing flexibility, right, compared to a standard purpose-built for every industry, everything controller from a standard industrial robot supplier, to the point where we turned a advanced motion controller that's designed for the machine tool world into a kinematic for a 6-axis robot application, which is kind of interesting. The other one is the training. The standard platform of Operate, which is basically a machine tool interface, gives you the flexibility to either work in a robot-like position mode or use G-code. So it allows for flexibility, which a standard robot wouldn't do. So now we get, still to this day, you get to use that flexibility where complex motion, if you have to move about a part, the machine tool control can predict it's going to look way far ahead and get the best accuracy that you possibly can get based on the mechanics. Where a standard industrial robot's like maybe a one-line look ahead, it's going about an arc in 3 points. It's very sloppy. Aside from that, we can first give someone a digital twin. Siemens offers to create my virtual machine product. So we now, as the end user or Think-PLC, can generate a model that actually moves, and you can get you about 90% there to running a machine. So I'm sitting at my desk basically commissioning, where I can take that same commission file and digital twin and come out here and deploy it on the plant floor. And what that does is just speeds up time to market. It's less time in the field, that's less expenses for travel, and it's just you're working bugs out in simulation. Siemens had a deadline, and an extremely tight deadline. They needed a solutions partner that within weeks could source all kinds of materials, put them together in a package. It would be something that they could showcase to many customers moving forward. And Siemens looked at many companies because they were like, we got to get this done. End of the day, we got to get this done. I think the flexibility and the willingness to work, we're already a Siemens solutions partner. We have a track record. We have a track record with robots and obviously the control system, which is the most complicated and most critical part of this system. And so they chose us for all of those reasons, and we executed. First thing is support. I mean, at the end of the day, once we're happy with the product, once we're running and it goes down, is what support you have, what's the ecosystem look like for that. And so you have the structure as a global footprint with Siemens, other than like regional based for other manufacturers. So I have a global footprint, machine tool groups all over the world, different. So as an OEM, if you ship this out to multiple places or plants all over the world, there's no question you're going to get a part, you're going to get a service person, things like that. So on the forefront of that is the system itself is the incredible training solution. It's available for free. So if you go on the CNC4U website, you can sign up. Siemens offers courses virtually, so to get familiar with the control. So what that allows you to do is, traditionally, you onboard a new operator, you either had to hire the OEM, the integrator, or the end customer had to write SOPs and develop manuals about the whole control package work. Well, guess what? You can throw that out the window because all the training on the Operate interface, this is a standard format Operate interface, can be customizable, but this is a easily trainable thing. You can take a guy right from a milling machine in your shop and you can stick them on this and they're going to be able to operate it. So the training resources are big. The digital twin is huge. So we can go train virtually, right? We can sit them down. They're going to be running this thing. If they crash it, who cares? But you can actually get them familiar with the control, comfortable to where they can come out here and confidently run it without help. The ideal end customer for a package like this, it's what I would consider an OEM and an end user. why you would have an OEM think about something like this. One, they can provide their own package, so ongoing support maintenance is managed completely by the OEM, right? Fully customizable. And then what this thing can do from a control perspective is unreal. So you can control an entire machine with multiple robots, multiple machining processes, or no machining processes can be done out of this control. So what we're doing is we're not taking pieces and parts from multiple vendors and connecting them through Ethernet or some field bus technology, and you have pieces and parts not working wholly together as one. This is one system that could run an entire plant, essentially. So incredibly enough, as well as all the safety system, everything integrated in. What we do as systems integrators traditionally is we buy the robot, and then we buy the PLC from somebody else, and then we have to put this together as one live package. This is all in one. We're not piecemealing things together from multiple brands. They all work. It's one place to support them. So the other thing is from an OEM perspective, you're going to own this solution from then on. So your customer is going to want to call you back. You're going to be the people that can create features, but they have the breadth of Siemens to support them as well. They can call the tech support center and get help with the standard alarms and things like that. But you can really bring the OEM package as yours. You can really own the mechanics and electrics of that system. The end user, the obvious thing is accuracy. I mean, just the accuracy at which can get created through a machine tool control, the complex motion, the amazing line look ahead for interpolation this can create, as well as the multiple channels. So what's interesting is if I had 10 robots, I could run 10 robots off this one control. I could run 10 different programs at the same time with one interface. Okay, that's built in. That's inherently just part of the structure. The other thing is with this one control, I can have one system in e-stop and another system not in e-stop or out of the zone turned off. Just the flexibility is unreal with the capability at which a machine tool control has. The other flexibility of it is this is based on TIE Portal, which is very popular software now. Siemens offers for all their factory automation products. If you know TIE Portal, you'll know the back end of this for customization. Okay, so with TIE Portal, the standard drives, the standard I/O, it's not hard to find a controls engineer these days that's not had training or experience with the TIE Portal and the Siemens product line.
So this thing can run
10 robots. 10 robots, one control. And they call it channels, so you can have 10 channels. The amazing thing is like one channel can be doing very complex interpolation while the other one's doing simple or in e-stop. They act as 10 different machines, and you have these mode groups associated with it that allow for such a thing to happen. Yeah, so where Think-PLC really plays is we've come up with a solution that you're not having to put this together yourself, especially at the end user level. You can call us or call Siemens. We work as partners, and you can get a package together without worrying about having to completely design this yourself. We designed it. We work through the headaches. You get a set of drawings. We'll customize this. It's fully customizable. It's like a car. If you want different color paint, you want to move something, you want the screen different, we're so flexible we can adjust that to whatever look and feel you need.
Okay.
So the control package you see here for 6 Digma is our standard design. We've recreated this many a times where you have a display. You do have an IPC, so you have the flexibility of a Windows computer here for other software. It's common that folks will want other things running, such as CAM software or cameras or whatever else you may think of. So pretty straightforward, really clean. All the operates in the touchscreen. But the big one is we're using a machine tool control for robot, and that is that we have the HTTN as part of the package. So you have your dead man switch, your e-stop, your full VNC view to operate. And so you really don't need a machine control panel or other button functions. You have it all on the HTTN here with that. So as you walk around the cell, obviously these robots, you have to get in to see what you're doing. Use the HTTN, feed rate override for speed control, start, stop, jog, reset, all that good stuff. So you have the flexibility back and forth with that. That is removable, and you can change the cables. So if you need 15 feet or 60 feet, you can change it to whatever you need. So inherently from a safety perspective for plant design, what we did is changed up for UL purposes and arc flash purposes. We wanted the low voltage control to be accessible and the high voltage control on the backside to be more of a enclosed, safeguarded interlock system. So on the front, if you need to access the control package, you can gain access to all the low voltage controls. So we have the NCU, or aka the brain, the IPC, which is optional. This is option with a Siemens IPC industrial computer for advanced safety stuff. And then also any other low voltage control and IO can go in here. But as you notice from the background, everything's connectorized and pre-wired. We can be as flexible as one needs for the connection points, but we have a standard package that works for most applications. Standard design with the control package from Think-PLC is on casters, but the casters are flat base, so you have more secure. You don't have to worry about something tipping over, but it is movable. Most of these applications are done for setup, and they're actually for quick setup. And so company doesn't need unistrut bracing or framing and things to mount the control system, but they could. You can completely change it. We have the flexibility that this looks completely different in one needs. And that's what we expect out of some of our OEMs, is they'll want to build this into the base frame of the machine, and you don't even see an external box. It should just be built into the whole package itself. That's the flexibility this gives you versus someone else's robot controller that you have to use, that you have the flexibility. So the cost of ownership with that is going to be decreased for the OEM. So it's going to allow them to be more cost competitive and more aggressive when they go in. Because once you build this package and you have it integrated, then you're actually repeat that design, and you're not paying for the premium of a design solution every time. It's your design. It's already been bought and paid for. So the high power side has a disconnect on it, so you don't have to worry like some where you have to have an external disconnect to meet local safety standards. So you have a lockable interlock disconnect in the package. We have a couple of solutions for cooling. Most applications, unless you're in a dirty environment, we can do fan cooling. So we have thermal analysis done on the cabinet, so we know exactly what the control needs from a dry perspective and what kind of heat it's going to generate. But what this does is keeps the operator or the maintenance technician outside the enclosure, the high voltage stuff versus low voltage stuff. So as you see, standard Dynamics drive system. We have an NX module for optional additional axes. So everything's just kind of nice and neatly packaged up. Again, it connectorizes on the side. We can customize any connector solution you need. We can add additional IO, any additional power needs can get added in. This customer needs a valve prep, so we added that to the side for them, as well as a couple other little features. And yeah, from that perspective, it's pretty easy. So power entry on this side, pretty straightforward. You got your Dynamics drive module here, where the active in-feed module. So this is a power saving active line feed. So all the regenerative energy doesn't dump through resistive breakers. What it's going to do is recover that energy to be as cost effective from an energy standpoint as possible. So we're recovering energy to the line. All your motor modules come in here. We do put bolt hole patterns in here for additional axes. So if the customer wanted to add something like a robot on the rail or additional external axes, it's here ready to go for them. They just add it into the DC bus. So like most controls these days, you have some kind of operator interface. This is a reusable interface that is has your G-code, operations, HMI, has 4 customizable screens built in, all the tool management, and that's one additional thing from tool removal to tool add, the advanced tool management feature in here. You have full operation control from a jogging perspective. You can take over management from jog to auto, G-code to some of the other control here. So on other applications, you'd have to customize a screen like this from scratch. We're talking hundreds of hours where it's already built in. You can customize this screen as much as you want through different tools built in and external software. But Operate has everything you need. It's been around for quite some time. It has enhanced over the years. What's neat is I learned with customers is all the additional software packages like MindSphere Insights Hub for collecting data, Energy Suite, the things you can add into this if you want to do those things. It's not a from scratch yet again project. It's already built in. Siemens has thought these things through. It's inherently already in there. So there's a lot of features that you can add, and just like a machine tool control, they have all this feature function. We can do the same thing with the robot control now without a lot of effort. So with the HT10, you have the flexibility to walk around with the machine control in your hand, which is really nice. It's really easy to do anything you need to do here, whether it be call up new G-code program, operate, or jog the machine. You can do so at your own wheel. So as you see, I'm controlling the machine. You can advance the speed or control. You have same visibility you'd have on operate, but it's a remote view, and it acts as going to be as your tool for commissioning and programming. And again, the code running here is standard G-code off the shelf that any CAM software can create now, like Fusion 360, Siemens NX software, SolidWorks can do it as well. And so with that, what we'll have is interface, but also commands that act like a standard industrial robot controller.